Okay, I think we can get started here. So thanks for showing up. I know this is the last session in the day, so it's great to have you all here. My name is Tomer. I'm VP Product at MapR, and the topic of this talk is about real time. So talking a little bit about what are some of the potential architectures or combinations of technologies that you can leverage in order to achieve a more real-time data pipeline, or basically to get either to an insight faster in a more real-time way, or to actually take some kind of action in real time. So the problem with the word real time is that different people interpret that in different ways, right? And so we'll talk about some of the different possibilities. But at a high level, I try to make it kind of a practical thing, which is when events are occurring. So a lot of times when we deal with big data and Hadoop and things like that, there's a lot of event data that's happening. It could be logs in log files from security events. It could be user behavior, things like clicks on a website, et cetera. Those are the events. The question is how much time goes by between when that event takes place and when that event is either available for somebody to discover some sort of insight. So this could be as simple as using a BI tool on the data. Am I looking at today's data, or am I looking at yesterday's data? Or it could be, we have a lot of customers that do things like they do real-time bidding in the ad tech world. And so for them, it's really about how fast can you respond, and every response or every action that you take means dollars, right? You place the right ad, you're making more revenue. So that's about taking action. And as people get more sophisticated with Hadoop, the taking action becomes more and more important, because it's great to have an insight that says, well, I could increase the stock of umbrellas in these store in these months, right? But that takes time until that translates into revenue. A lot of the use cases that involve real-time action are actually things that influence revenue immediately, and that could be personalization of websites, et cetera. So let's start with the first one, because it's easier to kind of understand, easier to architect. So really what this is about is getting that insight as fast as you can. And so that has two combinations. It's how fast can I get data into the system? So I'm using Hadoop. How fast can I get data into a Hadoop cluster? Because if I batch upload the data once every 3 hours, then by definition I can't do analytics on anything or get any insight from data that's something that's happened in the last 3 hours. And then how do I then go and query that quickly? And so I don't know if you heard one of the talks earlier today that I did with a colleague of mine, with Jacques, who on Apache Drill. Well, Drill really enables you to do that kind of a real-time SQL-based analytics or exploration using BI tools. And Drill takes away, what Drill enables you to do is run a query without having all the overhead that you normally have with like a data warehouse. So you think about typically a data warehouse, I have to create schemas, manage the schemas, I have to load the data, I have to ETL it typically on the way into that system. All those things take time, so it's very rare to find a data warehouse that has real-time data. And so Drill solves that problem of not having to do all those transformations, not having to clean up the data, not having to define and manage schemas and update the schemas. And then we'll talk about some of the ingestion technologies in a second, which enable you to get the data into the cluster as fast as possible. So one option that you have is to use an NFS interface. So this is something that we added at MapR early on. We were taking advantage of the fact that MapR actually has a fully read-write file system and exposes an NFS interface. So you think about a MapR Hadoop cluster, it actually looks like a giant NetApp, right, or a giant EMC NAS. You can actually mount your Hadoop cluster directly from your app servers and have them stream or write their log files directly into the Hadoop environment. You don't actually have to go through what you would otherwise do, which is write the log files locally and then kind of ship them into the cluster every hour or every 10 minutes or something like that. So the NFS interface is really a really easy way to get data into the cluster, which MapR provides. Another option that you see in a lot of Hadoop deployments is this use of Kafka on the front end. And there's another system called Camus, which I think that's how it's pronounced, which takes data from Kafka on some kind of schedule and then loads that into or writes that into the distributed file system. So in these types of use cases, what happens is that the different application servers or wherever the event is getting generated gets pushed into a Kafka cluster. So Kafka is essentially a large scalable message queue system. And so all the events are getting pushed into the Kafka cluster. Those are called producers, the ones that are pushing it in there. And then you have Camus, which is a consumer from Kafka's standpoint. It's actually then requesting from Kafka every so often, give me the whatever you've received since this pointer in the message queue, and it writes that out to the distributed file system. So this is a good setup that does not require you to write a lot of code. You're basically using off-the-shelf open source components, namely Kafka and Camus, to take the data from the real-time data into Hadoop. There's some delay there because Camus is done on it operates on kind of a batch schedule, but at least it's easier than kind of writing your own kind of ETL logic. Again, then the kind of the third approach, which we see increasingly becoming increasingly common, is the use of HBase or MapRDB as the primary store of the data. And so you think of the distributed file system is great. I can append to the file, but a lot of times I don't just need to append to the file. I actually need some kind of real-time store where I can do updates or maintain on the fly kind of aggregations. And so really having a database. And the nice thing about this approach is that the database and Hadoop are the same cluster, right? I'm not, if you think of your other options, you'd have to load the data into some other system and then a MySQL database and then copy it into the Hadoop cluster or something like that. Here it's actually part of the same cluster, and you can run your analytics, your drill queries, for example, directly on the HBase nodes. So the way you deploy this is you deploy the drill daemon, which is called a drill bit, on every node in the cluster, in the HBase cluster. So you have the region server. If you're using MapRDB, then you have the MFS node in MapR. On that one node, you're running the drill bit there, and then drill takes care of the data locality. So when you submit a SQL query, whether through the interactive shell or you're going through a tool like Tableau or MicroStrategy or Click or something like that, doesn't matter. It gets to the drill bit gets executed in parallel on those nodes, and each node is reading data from the local region server. So you get that data locality. So this is another approach to getting the data in real time. It means that you are actually using HBase or MapRDB as opposed to just appending data into the distributed file system. So let's talk a little bit about the query side of things, because remember the first aspect of the real time, which we now saw three approaches. We saw the NFS approach, we saw the Kafka approach, Kafka Camus approach, and we saw the HBase MapRDB approach. That's about getting the data in. Once it's in there, you now have to be able to get those insights. So how would you get the insights in the fastest way possible? So we kind of saw the first generation of SQL and Hadoop technologies really try to re-implement the data warehouse, right? The Teradata on top of Hadoop, right? So tools like Hive, et cetera, you go and define your metadata, and then you can query it. What drill does is it really enables you to query data without having to manage that schema, right? So if your applications are producing some kind of JSON log files into the Hadoop cluster, you can then go and just query that data directly. The system knows how to understand what's in those files without you having to define a schema. And it can handle situations where schema is dynamic and changing and so forth. So a few things about drill, just as kind of an overview for those who are not familiar. Supports access to any data type. You can query any data source. Relational, nested data, schemaless data. It has connectors to various systems. So Hadoop, HDFS, MapRFS, MapRDB, HBase, MongoDB, and a few other systems as well. Cloud storage. And it allows you to run queries on those systems directly, and also allows you to do joins across different systems. A single query can do a big join. So it's querying the data in situ, and what we mean by that is that you're not having to pull the data out of those systems and into some other system in order to query it, which is a lot of times what you see people doing. It's based on an ANSI SQL foundation. So what that means is that it's not a SQL-like language. It's not HiveQL. It actually is SQL. So any tool that supports SQL will actually work with drill out of the box. And then drill does have some extensions that make it very easy to manage or handle kind of nested data. So how do you handle when you have like a JSON structure that's really deeply nested and things like that. And sometimes with JSON we see field names or the keys actually encoding data. So you may have like the URL as the key in a JSON file. So drill has some functions that let you kind of unnest that, so you can actually take advantage of that data as part of your SQL operators. Drill scales to thousands of nodes, which is great. We, in the Hadoop kind of land, we need that. But at the same time, it also scales. It starts from you can start from your laptop, right? So you go from a single node to thousands of nodes, and we've taken care to make sure that it's very easy to start small. So after this presentation, you can go and download it onto your laptop and just play with some JSON log files, right? And get familiar with it, and then you deploy it on your cluster, right? So you take let's say you take a MapR cluster with 100 nodes, you put the drill bit on every one of those 100 nodes, and now you can run those queries, right? So it scales onto and provides really, really high performance. And then finally, granular security. I think what we're seeing in the market, and especially MapR, where we're very focused on kind of the production Hadoop users in the market. Security is a very, very important thing for these users, right? We deal with the largest financial services and retail, et cetera, web companies. And security is very important for them. They need to be able to do authentication. They need to be able to control who has access to what data. So at whatever kind of granularity. And so what drill enables you to do is kind of define that kind of security with the power of a SQL expression. So I can say, this class of users, maybe the business users, only have access to data that's considered non-private, right? And so as long as I can express that with a SQL query, I create a view and enable people to access only that view, but not the raw data. And we see different users using even masking functions within these SQL queries, so that some people have masked data, masked credit card numbers, masked social security numbers, and other people have access to the raw data, like the administrators. This is a great quote from ZDNet. So it was kind of a report on the different SQL technologies, and really kind of understood the unique difference about drill when you look at this kind of SQL market. And it's I'll read the last two sentences here. So while drill uses SQL and can connect to Hadoop, calling it SQL on Hadoop kind of misses the point. A better name might be SQL on everything with low setup requirements. So even if you're only using Hadoop, right, you have some data in the distributed file system. You may be using something like HBase or MapRDB for your on that same platform. And that ability to join the log files in the distributed file system with the data in the NoSQL database on Hadoop, that's a very, very powerful combination, because more and more people are using multiple systems to access their data and different types of file formats, right? We actually find that a lot of the data today, in these Hadoop environments that our customers use are JSON files, Parquet files, a lot of the HBase data model where you have kind of a flat record, but really no schema. Different records can have different field names. And so traditionally, SQL engines look at the world like a kind of like a spreadsheet, like a CSV or a TSV. And if you have data in any of these other three quadrants, then you have to then convert it. You have to ETL that data into kind of that CSV format. And that's a painful process. It means having a data engineering team that can write all that custom code, make sure that code gets updated when the developer happened to add a new field to that JSON log file or the MongoDB table or the HBase structure. So it becomes really, really complicated. When we built Drill, we wanted to support all four types of data, and we realized that if we instead approached it from let's start with the most complex and powerful and flexible type of data model, then we could easily support all four formats without any data conversion. And so that's what we did. The internal data model in Drill is actually a JSON data model. It doesn't mean your data has to be in JSON, but what it means is that you can, because of this unique capability of Drill, you can then go query any type of data in place without having to modify it. And that's a very, very powerful capability, because it really takes away that whole ETL step that normally has to be done. And when we talk about real time, ETL is really the enemy of real time, right? Because if I have to go and do an ETL process before I can do anything with that data, before I can get my insights or take action, then it's not going to be real time. That ETL process takes an hour or 5 hours. It can't be real time. So we have to kill the ETL in order to do something that's real time. The main difference with regard to schema is that Drill does the schema on the fly. So what you see here is every other system that's ever been built requires a schema to be available to the query engine, to the query technology, before the query starts executing. And with Drill, that's not the case. The schema actually doesn't have to be known at all. So think about a select star statement. In a normal database, if you ask the database engineers, an engineering working on Oracle or something like that, how long it takes to implement like a select star. for the internal database engine. They tell you that's the easiest thing in the world. You just look at what columns are in the metadata catalog, and that's what you return. With drill, that was 3 months of engineering effort just to make that one statement work, because you have to understand, when we start doing a select star on, let's say, a directory of log files, JSON log files or Parquet log files, we don't know what's going to be in those files. We don't have any record that says that's what's going to be in that file. If you do have this defined in Hive Metastore, then we take advantage of that. But we don't assume that, we don't require that. And so we have to then be able to recompile the query on the fly as it's running in the cluster, and really understand the patterns in the data as the drill bits are observing that during the distributed execution of the query. So I often get asked, okay, so what's the role of drill in the enterprise data architecture? We have all these systems in the enterprise. What does this really do? How does this relate to the more governed systems, things like Teradata, for example, right? And so really drill enables in a unique way that initial phase of data exploration. So think of, you get the raw data, things like JSON, CSV, some dumps from some third party, your own internal logging systems, your own Mongo clusters, whatever it is, that's the raw data. Drill can just query that data. No initial setup, no anything. The data has arrived, you can query it. Okay, that's as real time as you can. The next phase there is I'm going to optimize that data. Maybe I've seen that I have a lot of people querying this same kind of JSON data set. Well, if I convert that data into a more optimized format, something like a columnar format, where the engine is then able to skip some of the columns during query execution, and it has much better compression kind of characteristics, that makes a lot of sense. But it only makes sense if that's going to happen a lot, right? So for some portion of the data, what we see is that people convert that to an optimized format. And so that, an example of that is Parquet. Drill can query Parquet files without any centralized schema. Just pointing at a directory of Parquet files, it queries and runs really fast. The next phase is, okay, I've decided that this data is really important. I want IT to manage it in a centralized way with schemas and everything. Well, then you just define the schema in the Hive Metastore, and Drill takes advantage of that as well. So Drill, if data is defined in Hive Metastore, it understands that schema and can use that as part of the query. And then finally, you get into the really kind of, and the icons at the top, by the way, represent kind of the volume of the data, how much data is there, right? So every step, there's less and less of the data that actually falls under that category. The last one here is relational data. And Drill, what we're not aiming to do, not with Drill and not with Hadoop, is we're not trying to replace the traditional data warehouse. Then this is how you're going to close the books at the end of the quarter and things like that, right? That's not what this is about. And so there's still some use cases where if you ask me, should I be using this, I'll say no. I think you should use your existing systems. They've been doing that for 30 years and they do that well. But for the majority of the use cases, when you're thinking about kind of data exploration and just analytics and real-time queries, this is a great solution. This is an example of a user that's using a customer that's using Drill and MapR together to analyze credit card transaction information. So they get information from all the retailers that they partner with. They give them all the credit card transactions. They're mining that data and providing insights back to those retailers. And they were using, before this, they were using other systems, and we're really having a hard time with both agility and scalability. So agility meaning just managing that schema. Every retailer is giving them data in slightly different formats, and it was just a whole really, really heavyweight process. It was also getting to the point where they were being very successful and growing, and the traditional systems that they were using, the relational systems, weren't scaling. Okay, so that talks a little bit about the kind of getting the real-time insights, right, from event to insight. Let's talk a little bit about how do we get to the taking action in real time. And so what we typically see, there's kind of two patterns that we see here. One pattern is you got your application servers, and they're interacting with the NoSQL database. In this case, it's an HBase or a MapRDB kind of a database. And then some things they're sending to Kafka. That could be like the event information they're sending through Kafka, which then goes through something like Storm or Spark SQL as a stream processing engine. And the actions here are either taken by the application server or by the stream processing system. And both of those are real-time things, right? HBase here is storing some state information. So if you're familiar with the Lambda architecture, this will look very familiar. If not, I'd encourage you to go read some articles. There's tons of information online about the Lambda architecture. But it's really a way to architect kind of a real-time system that takes advantage or can respond to events in real time by having kind of two data paths. One is kind of the batch path, and one is the real-time path. The real-time uses the stream processing engine to calculate various aggregations and results based on the most recent data, and then the batch kind of looks at the more historical side of things, and then they get combined at the presentation tier, for example, when you're showing a dashboard to the user. So this is kind of essentially the Lambda architecture. This is an example of a company that's doing this, and what they're doing is they're collecting information from, chances are actually if you've gone online today, and most of you probably have with your phones, events generated by all the switches and the routers and the network are sending information back, and that information is then being analyzed in real time to detect threats and understand what's happening on the network. So this is an example of a company that's doing that. They're using MapRDB. MapRDB is think of it as a much faster and much more reliable NoSQL or in Hadoop database, right? So you take HBase, get rid of the compactions, get rid of all the reliability issues, make it so that you don't actually have to operate any region servers, and things run much faster. That's what they're using. That's the red layer here, and they're running drill on top of that and using Spark streaming as the stream processing engine. So that Spark streaming is actually storing its state inside the cluster. So another example of a company that's doing this, and they're interesting. Their use case. This is a financial services company, over 2,000 servers now running Hadoop, running MapR. And they have a variety of different use cases. So they started with kind of real-time offer, something like a Groupon type application, but then re-architected the entire, basically the entire company, all the risk and the fraud on top of this. So you see all this different data coming in from different systems, and it's being used for everything from providing more personalized offers. So this is a very large credit card company. So personalized offers, they're doing fraud detection. Every transaction is stored in the system, and they're doing both the real-time fraud detection based on models that are being built here, but also also kind of historical, trying to understand if there's trends that you can't detect in real time, but you have to look at a broader portfolio of events happening across the entire customer base to identify those. And then they also go back in time. So if you look at the fraud investigation tool and fraud investigator, they're providing a solution, basically a visualization interface to their fraud analysts, so that when they suspect something has happened, they can go and kind of drill down and figure out what's happening, what's related to what, and all these sorts of things. So that ability to bring all these use cases into a single environment is super critical in making things real time, because traditionally what you have is kind of the database is on one side, the Hadoop cluster on the other side, and so in order for you to actually do or analyze anything in the Hadoop cluster, you actually have to export data from that database, let's say it's a NoSQL database, into Hadoop in order to actually do something with it. And then it becomes very non-real time, right? You've had to do that whole data movement process. So by bringing the operational applications on MapRDB in this case, and combining that with analytics on a single platform, that's then much more real time. So with that, I'll open up for questions if anyone has any. Okay, thanks for coming, everyone, and see you around here.